If we consider a rotating cylinder that has a moment of inertia of 0.0063 kilograms times meters a second squared, or meters squared, and an angular acceleration of negative 840 radians per second squared, and the cylinder has been accelerating for 10 seconds, and we would like to find the angular momentum and the angular kinetic energy. So first, we're going to start off by writing all the variables that we have known in black. So the angular acceleration is equal to negative 840 radians per second squared. Rads per second squared. The time that we are using in this is 10 seconds. And then the moment of inertia is equal to 0.0063 kgm squared. And after we have written all those out, we can now start to actually solve the problem. We are going to use green to find omega, or the angular velocity, because we will need to use that to find the angular momentum. So if we have omega is equal to alpha delta t. This is an equation that is generally used in rotational dynamics and is very common. So if we plug all those numbers in, we really just have W is equal to negative 840 times 10. A rather simple calculation, which turns out to be negative 8,400 radians a second. Now we can begin solving for the angular momentum, which I will be doing in red. So if we bring it over here, and we have the equation L is equal to IW. So L being the momentum is equal to the moment of inertia times the angular velocity. So if we plug in our known variables, we have L is equal to 0.0063 times a negative 8,400 radians a second. And that will end up being a rather measly number of negative 53 kilograms per meters squared over seconds. All right. The second part of this question is asking for the angular kinetic energy. So we will use the rotational kinetic energy, or the same as angular, the equation of Ke is equal to 1/2 I omega squared. And we have both of those variables, so we can just plug them in. So Ke is equal to 1/2 0 times 0.0063 times another negative 8,400 squared. Actually, it's just that squared, so we put it on the inside. Right, actually, no. Never mind. Minor mishap, my bad. So now, when we find that, we have, it comes out to be a 2.2 times 10 to the 5th joules. And here we go, we have our final answers of L is equal to negative 53 K, or actually, I'll write it in a different color to make it stand out. Here, we'll do it in, what color do you want? Let me know in the comment section below. But we'll do it in a sort of crimson. And so L is equal to negative 53 kgm squared per second. And then the kinetic energy, KER, rotational, is equal to 2.2 times 10 to the 5th joules. And that will conclude our lesson on rotational dynamics, moment of inertia, angular momentum, and angular kinetic energy. Thank you for watching, and tune in next time.